All right, so we have been talking about turbochargers, and yesterday we pretty much left off with talking about superchargers, internal superchargers. And the nice thing about internal superchargers is since they are geared or belted to the engine, the faster the engine goes, the faster the supercharger is going to go. The slower the engine goes, the slower the turbocharger goes. So they're connected together and engineered to work at the speed that it's going in. And so you don't need any additional controllers. It's just pre-programmed into it. But when we get into turbocharging, everything changes. And that's where we're going to spend most of our time is looking at the controllers that operate the turbo systems, because a turbocharger runs independent of the engine. There we go. So the basic operation of a turbocharger, there's your pointer around here. All right, so we have air intake. What comes before the air intake? All right. Okay, we got an air filter. Let's see. This looks more like a continental system, but it can go either way. All right, so air filter is going to come in and it's going to go to a compressor. What kind of compressor is this? Centrifugal compressor. What's driving the centrifugal compressor? The turbine is driving the compressor. All right, so it's going to come through centrifugal compressor, through the center, out through the edges, compressed. Next, it's going to hit the throttle body. What else could we say is the throttle body? That's why I say it looks more like a continental system with a throttle body, but our fuel control unit, right, would be here. But in this case, it's the throttle body. So now we have, what is the, between this spot right here, the compressor, and this right here is known as what? Diffuser. No, I'm thinking something else.
Upper deck.
Upper deck pressure. So this is the upper deck between the compressor outlet and throttle body. From the throttle body to the cylinders, it's known as? The manifold, intake manifold. So this would be manifold pressure. Over here would be upper deck pressure. It goes into these cylinders. This is a 6-cylinder engine. Out of the cylinders into the exhaust. Now, once it gets to the exhaust, with a turbocharger, you have to have a Y gate, W-Y-E, Y gate, where it's going to have a choice. Is the exhaust gas going to go up to the turbine wheel, or is it just going to go out? And the waste gate is the thing that makes that choice. So if the waste gate is open, then the exhaust gases are going to bypass the turbocharger. So waste gate open is the same thing as saying turbine off, if you will, or turbo off. When the waste gate is closed, then it's going to send the exhaust gases across the turbine. Turbine speeds up. Compressor speeds up. The compressor speeds up. Upper deck pressure goes up. If upper deck pressure goes up, in theory, well, I shouldn't go that far. It can cause more pressure over here, but not always. So, all right, so we got the basic system going on here. So we have to have some way to control this wastegate. And there's a lot of different ways that the wastegate can be controlled. And we're going to go through all of those different ways. We're kind of pressed for time today, so I'm going to have to be sort of quick about some of our notes. So pay attention. All right, there's just a cutaway of a turbo. Let's see, we have, which side do you think is the compressor? This side or this side? Right or blue? You guys are just so stinking smart. It's the blue side. Why is this red over here? Because it's hot. All right, so as air enters the compressor, it's going to come out through the edges, be compressed. There's a lot that we could talk about with this turbo. These things they take a punishment, because we're talking extreme heat over on this side, right? And so that means that you have to be very careful with what kind of seals you use in here, because those seals are going to melt. These are spinning at some extremely high RPMs. It means that we need oil fed through here. But we're going to talk about the fact that the oil, this temperature in here is so hot that oil that is left sitting there is going to coke. And if you coke that oil up, remember what coking is, that's when oil sort of crystallizes, then you're going to ruin your turbocharger. So pilots who care about their turbocharger, you will always see them do a long cool down period. It's like, why are they just sitting there? Well, it's because they had a flight, they came in, they landed, and they weren't going to just shut down their engine. They're going to sit there and let that that turbo cool way down and let the oil flow through here until the turbo is cool enough that when they shut down, that whatever oil's left in this area that sits there isn't going to coke on them. Yes, Hannah.
What is the size of what we're looking at?
They are various sizes. It'll fit in a bread box. Let's see if we can find one with a...
What's a box?
What's a bread box? Let's see if I can find a... Well, there we go. Does that help you right there? It's sitting right there.
Yes.
Okay. All right, just another cutaway. Yeah,
Should you do a cooldown period for non-turbocharged aircraft?
I would, if you need to. Yeah, I wouldn't want to bring a hot engine in, just, you know.
So what point does it go from cooling, because you're saying you shouldn't sit on the ground with, can you bake your cylinder, so what point does it go from cooling down to heating?
Oh, man. Let's talk about that a little bit later. I've got to get through turbos, or we're never gonna. We're gonna be doomed. What is? So the question is, at what point is it cool and you start, or are you risking hurting your cylinder sitting there on the ground? All right. So I'm thinking about when I. There we go. So when I fly into here, you just got to use common sense, I think. Well, maybe that's the wrong thing to say. So you're coming into an airport like this. Well, what were you doing? Were you doing a long descent? What is the temperature outside? What was your power setting coming in? If you land here, you got 10,000 feet of runway. Did you land at the numbers and then taxi 10,000 feet to the end? Or did you do like I do and land very long, slam on the brakes and take kilo off, and then pull up to the pumps and shut off your engine? You know, but then again, how were you flying on the way in? So on a normally aspirated engine, I don't worry too much about it because usually you have a descent coming in and it's fine. But you have to watch your turbos. If you were using it all the way in, especially if you got a twin and you're carrying power all the way in, and you land and pull off, no, I'd wait 5 minutes or so before I shut down. All right, just another cutaway, but this time we're going to have a bunch of controllers on it. We're going to talk about those controllers here in a little bit, maybe. All right, turbocharger, let's see. An external compressor driven by a turbine wheel that gets power from exhaust gases. All right, your basic operation, which is what we just went over. We have air travels from the cowling inlet through air filter, travels through or from the cowling inlet through air filter, then it goes from the air filter into compressor, as air is pressed outward by the centrifugal force to the outside of housing, the air is compressed. We can abbreviate that, put compressor. Compresses the gas. Then it goes, after the compressor, what's the next stop?
Upper deck.
Well, yeah, okay, so it's the upper deck from compressor. To the fuel control unit. from the fuel control unit to what comes next? Yep, we'll say through manifold. Two cylinders. Combustion. We'll call it combustion air, or we should call it exhaust. Combustion air enters exhaust pipe. To the Y gate, or to the Y, I should say Y. To the Y. From the Y, exhaust gas. Exhaust gas goes into either, what do I want to say there? Actually, yeah, either turbine wheel or overboard. And what decides whether it goes overboard in turbine wheel is called what?
Wastegate.
Wastegate. Okay, excellent.
What do those look like?
What is what?
What's a wastegate look like? Just like little boxes.
It looks like a pipe. You go straight or out with a valve in it. Crudely drawn. I'll show you some pictures. All right, components. Let's see, I got a picture of a wastegate. Here's a wastegate right there. That's the actual wastegate, not the Y part. That is right in this area right here. So it's in the exhaust part. So it's near the end of the exhaust.
Wastegate open and turbo off.
Wastegate open, turbo off. All right, so components. We've got the turbocharger. Made of Inconel. Not all of them, but I found that. What else is made out of Inconel?
Your fire safety.
Continuous loop fire detection system.
What else? Same stuff as exhaust valves. That's some high temp stuff, right? And of course your fire loop. Why would you want that made out of Inconel?
So it doesn't melt.
Yeah. Or we could make it so if it does melt, it sets off the fire alarm, right?
Yeah.
And
It works by rounding out and it sets off the alarm. So.
what does TIT stand for?
Turbine.
Turbine inlet temps can reach as high as 1650 degrees F. That's very high.
So turbocharger is the turbine, or is it the whole?
It's the whole thing. So you have the turbine wheel and the compressor side, but together as a unit, we call it a turbocharger, the whole little thing. Let's see, precision balanced rotating shaft with radial flow turbine on one end and a centrifugal compressor on the other. Let me see, RPM from about 2,000 RPM to as much as 125,000 RPM. So it's moving. By the way, 125,000 RPM works out to be 2,083 revs per second. That was really hard to count. has a pressure, pressure oil fed, plain bearing.
Why a plain bearing?
I know, why not ball bearings? What? Heat dissipation's a good answer. Wonder if they can handle that speed.
Ceramic bearings can only go to 50,000.
What's that?
Ceramic bearings can only go to 50,000.
Okay, so ceramic bearings can only go to 50,000. But that's where they designed them. So it's pressure oil fed plain bearing. What happens if you run out of oil on a plain bearing?
Start eating metal.
It dies. It quits. Let's see. Well, it runs about 30 to 50 psi, so it's reduced a little bit. 1 to 2 quarts per minute. And oil may be returned by a scavenge pump. All right, there have been problems. Well, this is an area that gets messed up. So on these turbochargers, it requires all of this oil, but sometimes people get fittings mixed up, and I know there's another fitting in the system that I can't think of which one it is off the top of my head, but it's got an orifice on it, and you don't want that orifice connected. So if you have an orifice, a restriction going to your oil feed going through there, then you're going to restrict the oil to the turbocharger and it's going to burn up. And so there have been cases where mechanics have continuously put the wrong orifice, an orifaced restricted fitting on the turbocharger because they are on the engine, and burn up turbochargers like a couple of times before you figured out exactly what happened. So don't do that. So you got to be really careful which ones you're hooking up. And what number am I on? Turbo components. 1, 2, 3, 4, 5. I'm skipping some stuff. We have the Y gate, or the Y, W-Y-E, provides a path to either turbo or exhaust, or waste, or overboard. And then we've got the wastegate. All right, so the wastegate has to be installed in the exhaust line. So installed. And by in the exhaust line, I mean we get to the Y, and it's got to go either to the turbo or overboard. So it's got to be not in the route to the turbo, but to the overboard. Otherwise, everything we say here isn't going to make sense. So when open, I'm going to abbreviate exhaust by EX. Exhaust gases leave exhaust and bypass the turbo. To overboard. Got that? That means turbo off. So open is off. When closed, exhaust gases are routed to the turbine, which spins the compressor faster. That is turbo on. So closed is on. And if you can get that straight, things will go a little bit easier. there are 3 basic types of wastegates. All right. So let's see. So review. We're talking about the wastegate, which is located right here. It is in the exhaust side of the Y. So here's our Y right here. Y? I don't know, because it is. So there's our Y. If this is open, turbo is on or off? I heard somebody say on. Off. This is open, turbo's off, because gases are going to take the path of least resistance. So they're going to want to go out this way, not through the turbine restriction, go out this way, out and down, right? Okay. If it's closed, then it's going to be on. And I'll tell you a secret. It's never all the way closed. I'm sorry. It's never in a position where it touches. It's never all the way closed. And you always have turbine wheel movement. You never want the turbine wheel to sit still, because you still get hot exhaust gases that will come this way. And if this was sitting still, it would bake and have uneven heating. Uneven heating is going to cause stresses. And so you don't want that. And it never goes all the way closed, because with this butterfly valve, or to make contact, it could actually kind of melt or weld itself in that position. So there was a little bit of gap there. So turbine is never all the way off. You always want it rotating, even if somewhat slowly. All right. So 3 types of wastegates. Well, this is just out of order. All right. Manual controlled system. So I like this. It looks like it's just a little faucet. I don't know what the idea was there, but what you would have in a system like this is just another knob next to the throttle. So you'd have throttle, mixture control, prop, turbo. So you would just, it would be standard procedure. Forward is more, back is less. If you pulled it all the way back, it'd be off. And so what you would do is you would open up this right here. And if this is open, the gases are going to go this way. Nope, it's easier to go this way and out. And as you push forward and you say more, because it's forward is more, it's going to close this off. And that will put all of the gases going this way and speed up the compressor, which then puts more upper deck pressure. And in this particular case, they put a pressure relief valve, which is basically just, it's a poppet valve. And when this is set at a certain pressure, it just opens up and relieves any excess pressure that's built up. The idea is not for the pilot to say, well, you know what, let's just go max turbine and let this thing take care of it. I mean, you could. And the problem with this system is it's a lot of work on the pilot. One of the there's some problems with turbos. You guys know about turbo lag, but there's also something called bootstrapping, which leads to throttle sensitivity. So the thing about a system like this is, and let's just figure that we've set the wastegate at a spot, all right? So you're the pilot, it's a manual wastegate, so you just set it at some spot. And so I'm just gonna, it's kind of like a mid-range, I'm fine with that. So what we don't have here is the throttle valve. So we'll say, so we got a throttle valve here. We'll just put it over here, the right spot. So we got a throttle valve. So as the pilot, we'll just take it from sort of a cruise spot. And if I add a little bit of throttle, and I don't change anything else, but I just open the throttle a little bit more. Hey, I just wanted just a little bit more power out of my engine. Well, what's going to happen? Well, I'm going to open this up a little bit so it's a little bit more air through. By a little bit more air through here, I'm going to get a little more air out this way. A little more air out this way is going to go a little more air this way, so it's going to spin this faster. If this spins faster, this is going to spin faster, and that's going to create a little bit more air this way. That air is going to reach that through here, which is going to make a little more air, which is going to make a little more air here, which is going to come back around, make a little more here, which is going to make that go faster. You see what's going to happen? It just starts spiraling out of control. So then what you do is you have to close something. So, oops, overboost a little bit. It's going higher than I wanted, so close this back down. So then the opposite happens. Well, a little less, a little less, a little less. And so then it becomes this hunting back and forth. So in a system like this, there's a lot of work trying to hunt and find and do that. So I've only seen one aircraft in my travels that had something like this, and I think it was because it was an aftermarket kit on a 182. So, but this is the very simple way, and it's just a good way to kind of explain, hey, this is how it works. So now what we have to do to eliminate pilot workload is figure out some way to make this more automated. So we can have a manual controlled system, or we can do something that is similar, but just do an interconnect. And it's, well, in my mind, it's similar to when we talked about the Continental, where if you move the throttle on the fuel control unit, it moves the butterfly valve, and there's a linkage between the two, and you can adjust it. Well, same thing here. So now we're just saying, okay, so we're going to connect the wastegate to the throttle, but somebody's got to think this through and say, okay, if the throttle is at this point, the wastegate's got to be at this point, and it's got to be kind of timed in there, set up correctly. But it's just one way to do it. So it's just a very manually controlled interconnect system. So as you give it more throttle, that means you're going to want more power. More power means this should go open or closed? Closed, okay. And so there you have it. And then you have one simple pressure relief valve that's set to relieve pressure that's in excess of anything that there is.
Kevin, can you go back?
No, yeah.
Why then, how would that avoid that runaway that you were just talking about?
Doesn't really.
Doesn't?
The bootstrapping and the throttle sensitivity, it doesn't. You're going to have that problem with this system and a high pilot workload.
Then what does that interconnect relieve?
It just makes it a little easier, so you're not having to do two knobs at the same time.
Okay.
It's like, yeah. Because with the other system, so what you do before you take off, like the pilot I flew with his, he'd bring the power all the way up to max power, feet on the brakes, and then start dialing in the turbo until he got the pressure that he wanted, then release the brakes, then take off, then start, then you start rolling. Well, then you're going to, boost is going up a little bit, RPMs go up a little bit if you're not careful. Then you have to start adjusting everything as you go. It was a lot of work. I was like, wow. So let me see. So I said there's 3 types. Let me see. One type I didn't talk about, but I could, and believe it or not, this Piper Seneca is this way. This is just fixed. There's no adjustment at all by anybody. I think I have a. Yeah. It's just an absolute. It's a big bolt that goes in there, and it's set at the factory, and you really don't ever change it, and you hope you don't ever have to, because if you've ever had to try and change a bolt that's been sitting in an exhaust system for a couple hundred hours, you're not going to move it. No. And if you are moving it, then you have to ask yourself, why am I moving this? What's something else going on here? This shouldn't be adjustable. Not once it's set. So, but that's Piper Seneca's used that, which is actually a nice plane, very simple system. All right. All right, so I had three basic types of wastegates. We have the fixed, which uses an adjustable screw. And I'll say adjustable because it's really not. Uses an I don't even think screw is the right word. I think a bolt is a better word. Adjustable bolt to block a certain amount of exhaust. And that's all it does. And then we have manually operated. Which means it's pilot controlled. Let's see. Manually operated. We can put pilot controlled with a push-pull cable. Or we can have the interconnect. And the manually operated, let me see, can I do this? Yeah, this would be like 0.3, which is kind of, it's either that or that. And so we'll put these systems, manually operated, use a pressure relief valve. In the upper deck to keep pressure at set limits.
So it's basically, automotive terms, it would be a blow-off valve.
That's exactly what it is. So, well, no time for stories. My son hooked me up with a Ferrari dealership, and so we got to take a Ferrari out. Sorry, Westlake Ferrari but yeah, I hit that pop-off valve on that Ferrari. It was loud. It scared me. I thought I broke it.
How many PSI boost does it push?
It happened so fast. It had the tack was built into the steering wheel, and I had it manual, and I hit the throttle, and I just had no idea. I just saw a blur go to red. I hit the rev limiter and heard the pop-off valve go that fast. It was like, wow. It was faster than I could actually see it happen. I didn't have time to look down and see what had happened. It was quite a car. Can be oil controlled. All right, so oil controlled is where we're going to have to spend most of our time, because most of them are, in fact, an oil-controlled wastegate. And all of the controllers that are set up within the turbocharging system now, and we're going to add a bunch of them, are all oil-controlled. So before we do that, let's talk about the oil control, look at pictures, and see if we can make sense of this. All right, so we have a Lycoming density / differential control system. So what I want you to notice here is that it has a density controller and a differential control system. So it has two different controllers. We just got to find those. Here's my density controller here and a differential controller over here.
Pointer.
Oh, I thought I did. Sorry, but thanks for mentioning that. All right, so over here is my wastegate. Thank you. And this right here is the what? Because what is it?
Why?
Because I want to know. Who's on first? All right, so fresh air comes through the inlet, goes through the compressor, and the very next thing we're going to see right here, we have a density controller and a differential pressure controller. And over here we have our wastegate. Now what the yellow line is oil. So we have oil is going to come in from the engine and go right to a piston operated wastegate. So when the aircraft is off and the engine is off, this wastegate is going to be open. So it's in a normally open position, right? So turbo off is the normal position. So you get in the aircraft and you start it up. And what's going to happen is, the inlet fresh air comes in here, starts going this way. And we have a density controller, and I'll write some notes for you. But the density controllers, its job is to say, hey, I need full boost pressure. This guy's job right here is to make sure that the engine can operate at max power. And so it's going to, whatever this is going to be set for, it's going to want that. So I need full power. I need max turbo output. And this job over here, the differential pressure controller, notice it's sensing two things. It's sensing the blue and the green. So it's sensing upper deck pressure and manifold pressure. This one's job is to say, sorry, maybe I shouldn't, I don't know. This is kind of like the man of the house here who doesn't think and just goes off running. This is my family. So this is me. Need more power. This is my wife over here. Let's be sensible about this. All right, don't be an idiot. So this one's kind of the don't be an idiot. and it's looking at the difference between these two. Because if there's a giant difference between these two, then we get this bootstrapping, this throttle sensitivity. So the sensible one over here, my wife, Sandy, says we don't need full power right now. We're idling. Idiot. But of course, I'm over here going, that's my job. We need full power. And the way this happens is oil pressure comes through here, and it just wants to run around and find its way back to the drain. That one's closed right now, so it won't. So this one's closed, so it just blocks here, because that's me. I want more power. But this one's being sensible. No, we have plenty of pressure, so it drains back to the crankcase. So as long as something is draining this oil off, then no pressure builds up here. If no pressure builds up here, then no wastegate movement. Follow? So we start it up. There's basically no pressure whatsoever. This guy's over here being the idiot. I need more power, right? But we're at idle, and this one's saying, okay, you've got 2 to 4 inches difference. How much do you need here? If I give you any more difference, you're going to have throttle sensitivity. You're going to be fighting this. You got to build a dam here to block all this air. So even a little tiny opening is going to allow all this air to come through. So you're going to have to pull it back more, and it's just fighting. So not a good thing. All right, so we got that going. And now as we open the throttle up a little bit more, this controller here is going to sense that difference. And as the difference between these two pressures starts equalizing, then the sensible one over here is going to say, hey, we're getting too close together. We need to drain off a little bit of oil. So it's going to drain off a little. I'm sorry. I should back up just a little bit so I don't lose anybody. Pen. So at first, it's got to block this off, right? So when we first start it up, it's all going to be kind of blocked off. So I got to block it up there. This is going to build up pressure, push the piston back, move this more to a closed position, and the turbo is going to start spooling up. As it starts spooling up, then the sensible one says, okay, we can let a little bit of pressure off, and then this thing is going to say, okay, we didn't need quite so much turbo right now. So it'll eventually find kind of a happy medium. All right, everybody follow so far?
Is there a diaphragm and then differential pressure control?
Not a diaphragm, an actual piston.
Other side.
Differential pressure.
Oh, over here? Yes, diaphragm. Yes, right here. Definitely.
Okay, so
They all have diaphragms. And poppets and springs, and I'll show you that in a little bit. That's what's sensing it. So it's, yes, so diaphragm with a little valve that can lift up and changes. So this one is it moves back and forth, and all this finds its happy medium, right? And it takes a little while for it to adjust. And that's the thing about these. They're not just on the spot. So at some point, we're going to have the throttle all the way open. And this controller here is going to be saying, whoa, wait a minute. We've only got a 1 inch difference between these two. That's not good. This thing's looking for 2 to 4 inches. That's not good. So it's going to block off all the oil and say, the sensible one's going, we need more. We need more turbo. Close, shut down, right? Because shutting this means more turbo. So more turbo. But now this one becomes a sensible one. Now, dear, let's be reasonable. We need to start bleeding off some. Where's my little bleed off here? Doesn't even show it here.
I think it's off the top.
I know. Oh, there it is. I think it goes out that way.
Yeah.
Not the best drawing. Okay, so this one here is going to start bleeding off because at some point, maybe this is set for don't exceed 34 inches. Then this will say, okay, we've reached 34. We gotta start backing off a little bit. And so that's the operation of what's happening here with this one. Questions on that? It's not really that hard. You just have to remember that when you block this off, this is going to close. When you open this, it's going to bleed off. The job of these two things is to sense something and either block off oil or let oil flow. Block it or let it flow. And remember that while you're dealing with all of this, at first started up, the oil was cold and thick. Then it starts warming up and getting thinner. And so these things are constantly in a state of flux and movement, trying to work with what they have to work with. Yes?
Are there 2 oil returns listed?
Oil return here and oil return here. Yes, because each one has its own. They are, is that parallel or series?
Parallel.
They're parallel. They operate independently. If it was in series, that wouldn't be a good thing for this one. So, all right. Can be oil controlled. Well, that means that it's a piston operated. Oil pressure is fed to a piston. We'll say at all times. You always have that oil pressure going right into the wastegate. As pressure builds, wastegate closes. Is that turbo on or off? Okay. So as pressure builds, the wastegate closes. That is turbo on. When pressure is bled off, wastegate opens. Turbo on or off? Turbo off. And it's not either or. It finds a spot in the middle. You can go all the way open, all the way closed, or in the middle, trying to get, so position. Is variable. Oops. Wastegate is never fully open or closed. If it's fully closed, I said it could actually stick, and you don't want that. Let me see. Oil cokes. At anybody remember what temperature oil cokes at? Want you to know because I gave it in Celsius.
Very hot. 100.
300 degrees. Oops, I wrote F. Jeez, Celsius. So 300 Celsius, which is
500 somewhere.
575 Fahrenheit. And that's why cool down periods are important. So cool down periods are important. Because what was the turbine inlet temperature? 1600 and some odd degrees is correct.
1650.
All right, so we got to get it down to 575, so we got to let it cool down. If you don't, what happens is the oil is going to go in those bearings, it's going to shut down, it's going to coke up, and then guess what? Now the turbo's off. When you're doing an annual inspection on turbocharged engines, the checks are you always have to pull off the inlet hose, and you have to do an inspection for FOD damage on the turbine, on the actually the compressor wheel. I can't really see the turbine too well. And then you also spin it, and you listen very carefully for any rubbing or any spots that aren't spinning nice. Don't put your finger in there while it's running, because at any RPM it'll come out kind of short. So in fact, they get the turbine side gets so hot, and these things spin so fast that they stretch, and they can actually get to the point where they'll start rubbing on the case. And if they're rubbing on the case, then they're not very effective. And then, so it's never fully open or closed. Why would I never want fully open? Is kind of maybe not the best way to say it, but the turbocharger's never fully off. And why is that?
Because you can melt the turbine.
The turbine to be
Uneven heating, which causes stresses and bad. All right, so let me think. What do we got here? Yeah.
Can exhaust gases from the turbine ever enter the compressor? like a leak?
No, but what can happen is the seals go bad and then oil leaks out. And then you get either oil. So if it goes oil, if you have a bad seal and the oil goes toward the compressor side, what symptoms would I find?
Like smoke.
Going toward the compressor side.
You'd have smoke come out of the exhaust.
You could, but more often than not, it's going to foul out plugs. What if it goes out the exhaust side?
Still smoke?
Now you got your smoke. Now you're more prone to get smoke out that side because it's oil going straight out. But yeah, you're right. If you're burning oil, you can still get some smoke. Let's see. I have automatic systems. And this is what we're going to talk about, what we just went over with the light combing systems. And we can do that right after the break.